Okay, so this exercise is solving an exponential equation by finding common bases, and this case is linear and quadratic. The previous exercise is the same, but it was only linear. In this one, we will have also quadratic exponents, which means that it involves multiple solutions. But it's the same as the previous one. We want to apply this rule of exponents when you have common bases. That means when you have a number, for example 5, raised to an exponent m, and if you wanted to make, if you want it to be equal to another number n, well, the only way for that to happen is when m is equal to n. And that way, we can get rid of the base and we can only work with the exponents. Okay? Which is exactly the same we did in the previous exercise. For example, if you have 10 squared and you want that to be equal to 10 to the x, the only way for this to happen is when 2 equals x. And you can't forget about this 10. You can just keep working with exponents. The same we're going to do for this exercise. So we have 27 to the 9 minus 7x equals 3 to the x squared minus 10x plus 45. You see, this exercise is called linear and quadratic exponents because here I can see that I have a quadratic thing, so it's gonna get a little bit harder, but not so hard. It's doable, it's feasible for this course. I know because of the title that this is a common basis. So first thing that I want to do is apply some kind of math trick to take this and this to the same base. I know that the 27 is a number that I can rewrite as 3 to the 3. That is the same as 27. Because 3 times 3 times 3 is 27. That is the math trick that I do for this exercise. Then the exponent, which is the same, equals 3 to the x squared minus 10x plus 45. Okay. And here, remember, this is a rule of exponents. Let's say you have a number a to the b to the c. It's the same as a to the b times c. That's a property that you should know by now. This is not part of this course, but if in case you forgot it, there it is. And I want to apply that rule here. So I will end up with 3 to the 3 times 9 minus 7x equals 3 to the x squared minus 10x plus 45. Alright. And this is where the problem starts because I have already taken it to the common base. What is the common base in this case? The number 3. We have a common base in both sides of this equation. So I can get rid of those. I can get rid of those and work only with the exponents. The exponent on the left side is 3 times 9 minus 7x. And the exponent on the right side is x squared minus 10x plus 45. Yeah, this is just now a quadratic equation. And let's solve it. First, we are going to multiply this 3. 3 times 9 is 27 minus 3 times 7 is 21. And that equals x squared minus 10x plus 45. Okay. I will take this number to the right side because it has an x on it. Anything that has an x on it, I want it on the right side. So let's do that. So I will have 27 equals x squared minus 10x plus 45 plus 21x. And now I simplify common terms. That is 27 equals x squared. Here I have two common terms, which are 21 minus 10. 21 minus 10, that is 11x plus 45. Yeah. But still I have a number here. I also want to take it to the right side to simplify terms. So I will have here a 0, and I will have here a x squared plus 11x. And this is just solving a quadratic equation. This is actually not the fundamental part of this course. What you know from this course is applying the logarithm rules. This is something you should know by now, but let's do it anyway. Simplify again. 0 equals x squared plus 11x. 45 minus 27. That is, let's do it here quickly. 5 minus 7. That is 8. 18, I guess. Yep. So I have 18 here. And now what I want to do is solve just a quadratic equation. And there are multiple ways to solve a quadratic equation. I can do that with the general equation, something like plus minus va4c over whatever. That is one option. That's like brute force if you don't know how to solve a quadratic equation. Or you can factorize. You can try to think what numbers can I factorize this. First of all, we can think of this as a perfect square trinomial. If you want to see if this is a perfect square trinomial, you've got to take the square root of this one and the square root of this one, but I see clearly that this does not have an exact square root, so this cannot be a perfect square trinomial. Next thing we want to check is, do we have common terms that we can factorize? Well, let's try to do that. Let's try to split this into x, that is multiplying x. I want to find two numbers that multiplied give me this number, but that added up give me this number.